So now I want to talk about when is a function differentiable and when is it not. So a function is said to be differentiable at a certain point if the derivative exists. So in other words, if you can find the derivative, then it must be differentiable at that point. So it is differentiable on an interval, means it is differentiable for every number in that interval. So you wouldn't be differentiable at a certain point, then you wouldn't say you're differentiable on that interval. So what I want to do is show you an example of where we have a function like that. So here we want to know where is f of x equals the absolute value of x plus 1 differentiable. My function is the absolute value of x plus 1, and in piecewise notation, this really means if your x is greater than or equal to -1, in other words, you're going to get a positive number in here, then it's just the thing that's here. So if any x is anything bigger than -1, like 0, you're going to get a positive number out. So you can just drop the absolute value bars. If x is less than -1, you get a negative number inside here, and you want to change the sign. So that's what this negative sign does, is it changes the sign to make it a positive number. Because remember, absolute values are always positive. So given that we have this separation of greater than -1 and less than -1, let's look at what happens if x is greater than -1. Then the absolute value of x is just, the absolute value of x plus 1 is just x plus 1, because we know we're greater than -1. H is going to be small enough. Remember, the derivative is letting h get really, really small. And so h is small enough, so we know that we're not going to get outside of, we know that x plus h plus 1 is still going to be greater than 0. We're going to make sure it's small enough. So that means the absolute value of x plus h plus 1 is the x plus h plus 1. We can just drop the absolute values. So we can now go to our definition of derivatives, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. And we can go ahead and find out what this is equal to. So now we're going to go ahead and do this as this is equal to the limit as h goes to 0 of absolute value of something plus 1 minus the absolute value of something plus 1. The first something is all over h, sorry, got my all over h. The first something is x plus h. So we type in an x plus h here. My second something is just x. So I put an x there. Now, we were just saying that as h goes to 0, because we're saying where x is greater than 1, we can actually just drop the absolute value bars. So this is just going to be absolute, this is going to be x plus h plus 1 minus x minus 1, because we take the negative sign through, all over h. This gives us the limit as h goes to 0 of h over h. That's the limit as h goes to 0 of 1, and the limit of a constant is just the constant. So that answer is 1. Cool. All right, so now we're going to look at what if x is less than -1. So if x is less than -1, then the absolute value of x plus 1 is going to be negative x plus 1 by the definition. H is going to be small enough, so x plus h plus 1 will also still be less than 0, because we're not going to get that far away to where this would become greater than 0. So that means the absolute value of x plus h plus 1 is negative x plus h plus 1. And let's go ahead and find that derivative. So this would be the limit as h goes to 0 of f is the absolute value of something plus 1. F is the absolute value of something plus 1 all over h. My something in the first case is x plus h. My something in the second case is x. But we just said that this absolute value is equal to negative x plus h plus 1. This absolute value is equal to negative x plus 1 all over h. So the limit as h goes to 0, taking the negative sign through is going to be negative x plus minus h minus 1. Minus and a minus is plus, so it's going to be plus x plus 1 all over h. Well, again, this is the limit as h goes to 0 of negative h over h which is the limit as h goes to 0 of -1. Limit of a constant is just a constant, so this one's equal to -1. So when h is greater, when x is less than -1, we get -1 as for our derivative. When x is bigger than -1, we get 1 for our derivative. So let's look at what happens if actually x equals -1. So let's actually look at that case there. So that would be the limit as h goes to 0 of f of -1 plus h minus f of -1 all over h. Again, this is that notation of f prime of -1. So we have the limit as h goes to 0 of the absolute value of something plus 1 minus the absolute value of something plus 1 all over h. Okay. Limit as h goes to 0. The something in this case, the first something is -1 plus h. The second something is -1. All right, so now we can go ahead and find that. So this is going to be the absolute value of h, because the ones cancel, minus 0. So it's just the absolute value of h. We don't even need the minus anymore. And then the whole thing is over h. Well, now we got to figure out what this is. Well, this isn't just 1, because this is the absolute value of h. So we're going to have to first do the same kind of thing. We're going to say, let's say h is greater than 0. Then this is equal to the limit as h goes to 0 of the absolute value of h over h. But since h is bigger than 0, we can just drop the absolute value bars. And this would be h over h, which is the limit as h goes to 0 of 1, which is, of course, 1. But h could be less than 0. So let's look at h being less than 0. Then this would be the limit as h goes to 0 of the absolute value of h over h equals the limit as h goes to 0. Now, if h is less than 0, then the absolute value of h is minus h. So that means we have the limit as h goes to 0 of -1, which is -1. So this is the limit approaching from below. So we can actually say that this is actually coming from above. Sorry, this one's from above. This one's coming from below. So the limit from the left is -1. The limit from the right is 1. And that means they're not the same. So that means the limit as h goes to 0 of the absolute value of h over h does not exist. And since it does not exist, then f prime doesn't exist when x equals -1. Well, actually, I can just, instead of having to say all of that, I can just say this. F prime of -1 does not exist. So that means that the function is not differentiable at -1. So we can say that f prime of x exists if x is greater than -1, or x is less than -1, but f prime of -1 does not exist. So f prime of x is equal to 1 if x is greater than -1. It equals -1 if x was less than -1. Graphically, what this looks like is we got this nice little V shape. This is actually the absolute value of x plus 1. That's what this graph is. And now I can draw in what I think the derivative is. Well, if we're bigger than -1, right here, we're going to be the number 1. So think about having, this is 1 right here. Think about having this nice little vertical line here. I'm sorry, horizontal line, starting at 1. But at -1, we wouldn't be that. So we're going to have an open dot. If we're over here at -1, less than -1, then our value is -1. And there again, there's an open dot because we can't beat those values. So this is actually what the derivative would look like for when we have this V-shaped. And that now gets us into the idea of things being differentiable. And that's a theorem that says if f is differentiable at A, then f is continuous at A. That doesn't mean that if f is continuous at A, that it's differentiable. It's only a certain direction. If it's differentiable, then it definitely is continuous. If it's not continuous, then it's not differentiable. So that's one thing that tells us when something is differentiable, is if it's not continuous. So this graph here is definitely not continuous. We have this break, the limit from the left, the limit from the right don't exist. So this is not continuous. So this one not differentiable because it's not continuous. Another place we just saw was this V-shaped. And if you've got this V-shaped, this little cusp here, then it's not differentiable. So if it has a corner, it's not differentiable. So we have not differentiable if it's not continuous. We have not differentiable if it's a corner. And there's one more place where we're not differentiable. And that is, if I were, remember, differentiable has to do, derivatives have to do with tangent lines. If I was drawing a tangent line right here, that would be the tangent line. If I were, and I could find that slope. And if I'm going to do it here, that would be the tangent line. I could find that slope. Well, the problem is if I draw it right here, there's my tangent line right there. But that tangent line is vertical. And vertical lines have an infinite slope. So they have no slope. So if we happen to have a vertical tangent, then we are not differentiable. So those are your three cases you look at for whether something is differentiable at a point, is you look at the graph and determine if there's a vertical tangent, if there's, if it's not continuous, or if there's a corner at that point.